If you wanted to pick up from where you are going to pick up, which is in the top that you are going to pick, no? That is the same scenario which is happening in the stack. If the stack pointer, or when we are at the maximum stack size, if the stack size is 5 and if I am trying to add 6th element, then that condition will be considered as what? Stack overflow. Push in the sense we are adding a new element to the existing stack. So what we are adding, that is what? Item or an element. Hello everybody, a warm welcome to one and all. Welcome to the first session of your chapter 2 and we are in the unit 2 of B.Ca.'s second semester subject called Data Structures Using C. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we are going to learn about this stack concept. That is what your second chapter of your unit 2. Let me go to the agenda of today's session. So in this session, we will be learning regarding what do you mean by stacks. You will be learning regarding the definition of the stacks, and also I will be discussing regarding how we are going to represent these stacks with the help of arrays. That means what is the memory representation of a stacks in a computer's memory and what are the operations that we can perform on the stack. That is also I will be discussing. Along with that, at last we'll see what are the applications of stacks that we have. That means where and all can we use this stack concept. First, now we'll learn about the definition of this stack now. So before getting into this, you just imagine, so when you go to cafeteria and all, you all going to see that trays will be there, right? So in order to carry your food and all, you have to use this tray, that trays. How the trays will going to be arranged? It will be one after another, right? So if you wanted to pick up from where you are going to pick up, which is in the top that you are going to pick, no? That is the same scenario which is happening in the stack. This is also what? It is an ordered collection of items in which an element may be inserted or deleted only at the same end. So here also we have a collection of elements, or you can call that as a collection of item that will be in some order. If I wanted to insert an element or if I wanted to delete an element, both has to take place only at the same end. You just imagine we have a room, in that we have only one door. Whether you wanted to enter, whether you wanted to go out of that room, you have to use that door only, right? So that is what in the stack. It will be a collection of elements or an item that will going to be inserted or deleted at a single end, and we are going to call that end as a top of the stack. Very, very important note. So that end of a stack is called top. That top, by making use of this top, we can insert or delete an element from there. And what is the opposite we have to that top? That is considered as base. So you just imagine here we have a stack. It will be a collection of elements or set of elements will be there. If I wanted to insert an element or if I wanted to delete an element, should takes place only at the top of a stack. So what is the opposite of this stack? That is what? Base. That you can see here, and also we are going to call this stack as a LIFO. That means last in, first out. The element which is inserting last will going to be deleted first. That is what? LIFO, last in, first out. Which element that we are inserting at last will going to be deleted first. So even in the tray example, right, they are going to have a set of trays there. If you wanted to pick up, you need to take the last tray. That means which has kept recently. So that is what? LIFO, or last in, first element. You can see the representation here. All these are the elements. This is called as what? Top of a stack, and this is considered as a base of a stack. And if I wanted to insert an element, that is what we can call that as a push operation. If I am deleting an element, that is considered as pop operation. So insertion at the top and even deletion is also going to happen at the top end. Then how we are going to represent this stack by making use of an array? Already you know about this array, right? It is a collection of homogeneous element, and all the element comes under a single name or a same array, and each element can be accessed by its index or by the position or a subscript, right? Then here stack can be represented using one dimensional array. So we are having three types of an array. 1 dimension, 2 dimension, and also we have a multi-dimension. So out of that, we are using one dimensional array in order to represent this stack. Then how we are going to represent it? The items into the stacks are stored in a sequential order from the first location of the memory block. You just consider here how we are going to represent an array. It will be in single direction, right? It can be row or it can be column wise. Let me go with a column type memory location here. So let me consider 1, 2, 3, 4. I have 5 elements and array's index starts with 0. Let me consider A of 0, A of 1, A of 2, and we have A of 3. At last we have A of 4, right? This will be considered as what? Top of a stack. If I wanted to insert an element to this position, then that needs to be takes place from here only. Fine. So all the items into the stacks are stored in a sequential order. It will be one after another. That means it will be in some linear order from the first location of a memory block. After that, the pointer top contains the location of the top element of the stack. So this pointer we have here, that considered as what? Top. So wherever we have a top, that will specify the last location. That means that will going to specify the top element of a stack. If I have all the 5 elements here, if I have all the 5 elements, then the top will going to be placed at 50. What if I only have 3? What if I have 4 elements? Out of that I have only 2 elements. Then top pointer will be here. That means where the top is indicating, that specifies the last element of an array. So, and also we have one more variable called maximum STK. That means maximum of a stack, that contains the maximum number of element that can be stored in a stack. So that mainly specify what is the maximum value that I can store. For example, if I have 50 here or if I have 5 elements, that will be the maximum size. It is somehow equivalent to n value in the array. Fine. So we have 2 variables, one is top and max top. Then how we are going to represent it? First we'll see here, if we attempt to add a new element beyond the maximum size, then we will encounter a stack overflow condition. Important, listen. So in this, if we are trying to add one more element when the stack is full, so if the stack pointer or when we are at the maximum stack size, if the stack size is 5 and if I am trying to add 6th element, then that condition will be considered as what? Stack overflow. So though there is a no space and it is at its maximum size, but we are trying to add a new element, then it will be considered as what? Stack overflow. And also if there is no element, consider I have only n elements, that means n is equal to 5 now. That means up to 5 elements we can store. But I don't have any elements there, every element got deleted. So now I have an empty stack. But if we are trying to remove an element which is beyond the base, then we can consider that scenario as stack underflow. That means though there is no elements or items, but we are trying to delete, that condition is stack underflow. So you cannot remove an elements beyond the base. Base is what? Already you know the representation. We have a top here and we have a base. So the element which is beyond the base, there will be no element beyond the base. But if I am trying to delete it, which is beyond the base, then stack underflow. Then we can consider that as stack underflow scenario. Fine. So here you can see the representation of a stack. The condition top is equal to maximum stack. That means top is all at the end and even maximum size is also there. Then what I can say, that indicates stack is full. You just imagine here I have 5 elements. Let me consider, or else let me take only 3 elements, 10, 20, 30. Okay. So what top is going to be used? That is used to specify the topmost element. Which is the topmost element here? That is what? 30. And the maximum stack size is also 3 here. Up to 3 elements I can store, but all the 3 elements are filled now. What it mean? Then the maximum stack is also in this location itself. So now top is also equal to maximum stack. Then what will be the condition for that we are calling? That is considered as what? Stack is full. Next we have one more thing, top is equal to null. That means you just consider one more example here. Okay, so now top is in the null. That means it will starts with 0, 1, 2. So beyond that -1 we have, that is also considered as null. So if top is equal to null, that means there is no element in the stack but we are trying to deleting it. Then what we can say for that? That indicates stack is empty. Fine. Here you can see that the representation, it consists of 0, 1, 2, 3, 4. These are the index or that represents the position, and also we have a up to 5 element we can store. Here you can see that 2 elements are vacant but maximum stack size is 5 here. Up to 5 elements we can store but we have only 3 elements. That is what top is indicating at the topmost element, and also we have a chance to add 2 more elements if I wanted to do so. That has to take place from the top end only. So here if I am trying to add 40 we can add, if I am trying to add 50 we can add, but if I am trying to add 60 then top will be here, right? Top is equal to maximum stack. If I am trying to add 60 which is beyond the maximum stack, then we can say that as stack is full. But here you just imagine I don't have any elements but I am trying to delete an element from the null position. At the time top is also equal to null or -1 position, then that is considered as stock is empty. So this is how we are going to represent a stack using array concept. Next we will see about what are the operations that can be performed on the stacks. So here we have 6 operations. In that first we have a stack, push of item, we have pop and peek, is empty, then we have size. So these are the operations which we can perform on the stack. We'll see the first one. What do you mean by stack here? If I wanted to perform an operation, first we must have a stack. Then how we are going to create a stack? That too with the help of this stack operation. Fine. It creates a new stack that is empty. When we are creating a new stack, that is of empty stack. No elements or items will be there. It is of empty stack. It needs no parameter and returns an empty stack. If I am calling this function, this is what we have a set of parentheses that specifies operation or a function or a method or a behavior. So this operation will going to help us in order to create an empty stack. Next what we have, push of item. Push in the sense we are adding a new element to the existing stack. So what we are adding, that is what, item or an element, so that it adds a new item to the top of a stack. So whether it is push or pop, that means insertion or deletion has to be from the top end. So next in opposite to this we have a pop operation. What it will going to do? It removes or it deletes the top item or element from the stack. Stack to create a stack, push in order to insert an element, pop in order to delete an element. Push or pop should take place at the top of a stack. Next here we have a peek. You just imagine I have 17 elements. So if I wanted to get to know what is the topmost element, what is the value of that topmost item, then I have to use an operation called peek. That will going to return the top item from the stack, but it won't do or it won't delete anything. But it will just gives us the value which is the topmost element, that is peek. Next also we have a is empty. That means we are checking whether stack is empty or not. I wanted to delete. If I get to know whether the stack is empty or do we have some elements, then it will be easy for us to delete. So for that reason we have a is empty here. It tests whether the stack is empty or not. So is empty, if I am doing that, if the stack is empty, then it will going to return true value. If stack has some value, then it will going to return false. At the time, is empty? No, stack is not empty. That has some elements, so that the resultant will be false here. Next we have a size. So if I wanted to get to know how many elements we have in a stack, then I have to use this function called size. So it will going to return the number of items on the stack. So these are the operations which we can perform on the stack. I hope you all understood. Let me move to the next operation. So that means in the total operation of a stack, we have a stack, push of item, pop, and also we have a peak is empty, and at last we have a size, right? So in that we need to concentrate on the push operation as well as pop operation. When it comes to the push operation, what do you mean by it? The process of adding one element or item to the stack is represented by an operation called push operation. So when we are adding a new element into the topmost position of a stack, then we are going to call that kind of operation as a push operation. We'll see the algorithm here. In order to do the push of element into the stack, then what and all we require? I require a name of a operation, that is push, and I require one stack, and I wanted to know the top. Why? Because insertion we are doing. If I wanted to insert, I wanted to insert an item or an element from the top position. So it is necessary to know the top, and I wanted to have a item that needs to be inserted into the stack. You can see here, stack is an array with n elements. If n is 5, then it will going to allow us to insert 5 elements. And top is the pointer to the top of an element of an array. If I wanted to insert an element, I wanted to know the top of an element. So top is the pointer here and item that needs to be inserted. So when we can insert into the stack, when it is not at the maximum stage, when top is not at the maximum stack, then we can insert. That means when there is a vacant space in a stack, then we can insert, right? So we'll see the first step here. If top is equal to n minus 1. You just consider the n is equal to 5 now. Then consider if n is equal to 5, then how many elements that I can store? 5, right? 1, 2, 3, 4, 5. Index starts from 0, 1, 2, 3, 4. What is the condition here? And we got to know that this is the top of a stack. Fine. Next. Here you can see that if top is equal to n minus 1, what is the value of n here? 5. N minus 1 in the sense, it will be 5 minus 1, totally it will be 4. Then what is the question or if condition we have? If top is equal to n minus 1, that means top is at the maximum size. If top is at this n minus 1 position, then stack is full or overflow. So when the top is at the n minus 1 position, that means we have all the elements in the total number of elements of an array. That means I can't insert a new value to the stack. So at that time what needs to be displayed? Print stack is full or overflow. When we are at the overflow condition, we can't add a new element. So just exit and we are going to end the if condition. Or else, so just imagine stack is not at the maximum size, or if top is not is equal to minus n minus 1. You just imagine top is here. So now I wanted to insert a new element. Let me erase this 40 and 50. You need to imagine now top is here. As I told, I will erase all these two. Now top is at the second position. That means top is not equal to n minus 1. Then what I can do? So if this condition become false, then it will come to the step 2. Top is equal to top plus 1. That means I need to increment the top pointer by 1. So now it is in the position 2. So now top plus 1 in the sense what? Top will come to this position. Fine. Then in the step 3, stack of top is equal to item. So now I wanted to give a value for an item which needs to be copied to the stack of top. You can see here we have a stack. What is the location of top here? You can see here that is in the location 3. That means within a square bracket in the position 3, I wanted to insert an element called 40. Fine. This 40 will going to be copied to this stack of 3 now. So now what we have in a stack of top, that is 40. Fine. Then if I have inserted or if I am done with the insertion of a new element into an stack, then we can return. So and also one more possibility is there. I wanted to insert one more element called 50. How can I do that again? Again this stack is not or top is not equal to n minus 1. Then there will be a space. Then I wanted to insert an element called 50 or an item called 50 to the position or to the stack top. At that time stack of top. Where it will be? Then it will be in the location 4. Stack of 4 or top of 4 is equal to 50. That element will going to be copied here. So that is how we are going to store or to insert an element or adding of new element into the stack will going to takes place. Then what if I wanted to delete? Then we have one more operation called pop operation. So here it is a process of deleting one element or item from the stack is represented by the operation called pop operation. So in order to do the pop, what and all we require again? I need a stack, I need a topmost element, then item. So here stack is an array with n element and top is the pointer to the top of the element of an array and item is the element that needs to be deleted. Fine. We are working or we are representing this stack with the help of this array. That is what we are mentioning an array here. So first step is what? If top is equal to null. Just imagine or consider again I have a set of elements or order collection of elements 0, 1, 2, 3. So now my top is at this location now and here this is equal to null when it is not in the 0th position, when it is in the -1 position. So above the 0, 1, 2, 3, below the 0, -1. Right? So null in the sense -1. When top is equal to null, that means both are at the same point which is beyond the base. So then I can say that stack is empty or underflow. We don't have any element but I am trying to delete an element. Then that scenario is called stack underflow. Fine. So then it will going to exit end of if. If there is no element, we can't do the deletion or a pop operation. So then it will return stack is empty or stack is underflow. What if we have a element? Let me consider here 10, 20. So now where will be top? The top will be in this location. So location will be 0, 1, 2. I have 3 elements. N is 3 now, but I have only 2 elements and top is at the location called 20. Fine. So now top is not equal to null. Top is not in the null position. Then I will enter to here item is equal to stack of top. So now whatever we have in a stack of top, that will be copied to item. How we are going to write that? What I have in stack of top? Stack of top. So top in the sense, what is its location? 1. What I have in stack of 1? That is 20. So now what is the value of item? That is 20. Fine. Then top is equal to top minus 1. What it means? We need to decrement the top pointer by 1. So indirectly it is, we are deleting an element called 20 from the stack. So top will going to be decreased by 1 pointer. So it was in 1. So now it will reach to the 0th position. So now we have a top at the 0th position. That indicates we have only one element, 20 got deleted and then at last return. If it is addition or a push operation, then top is equal to top plus 1. You can see here it will increment the top by 1. But if it is pop operation, top will be top minus 1. I hope you all understood regarding this push operation as well as pop operation. All these are important as well as easy topics. Fine. Next we go to the application of stacks. So it indicates where and all can we use this stack concept. We'll see the first type. It is used to reverse a word. So you already know how this stack will going to work. If I wanted to delete, insert for every operation that has to take place at the top of a stack. What if I wanted to reverse a word, then adding and deleting, adding and deleting. If you are doing it in a reverse order, it will going to give you the original. If you are adding original content and if you are taking it back, then it will going to reverse a given word. So in order to reverse a word, you can push a given word to a stack letter by letter and then pop letter from the stack. You just consider, let me consider the stack here. Fine. I am going to insert an element called A. That will be here and B will be here, C will be here. So what is my input? A, B, C. So now, if I wanted to do the pop or to delete a, first I need to delete C, right? So then here C will going to come first, next B and A. So then what will be the output? C, B, A. So this was my input. So this is my output right now. So ABC got reversed to CBA. In order to do that reverse of a verb, we require this stack. And also we can have a undo mechanism in text editor. When we are pressing a Ctrl Z, that will be in the stack, so we can get it back. That is what undo operation. And also we have a backtracking. So this is a process when you need to access the most recent data element in a series of element. Once you reach a dead end, you must backtrack. That means you can also take the example of navigation of your web pages. So once you are done with all these arrow mark, then you can come back, right? That is what backtracking. And also we have a language processing. For this purpose also we can have the stack. So compiler syntax check for matching braces in the implemented, that is going to be implemented by making use of a stack. So when we are writing a program, we are going to have a pair of curly braces. So that is going to match the pair of braces with the help of this stack. And conversion of decimal number to binary. In order to convert the decimal number to binary, which is machine understandable language. So for that also we can have this stack. And conversion of infix expression into infix and postfix expression. In order to convert this infix expression into prefix and postfix, we can have this stack. And also in order to have a quick sort, already you know about this quick sort. In order to have that application, we can have it as a stack. And runtime memory management. The stack is also going to help us in order to manage the memory at the time of execution, or runtime memory will going to be managed with the help of this stack. It's all about our today's session. In the next session, we will going to see about this arithmetic expression. So first we'll see what you mean by arithmetic expression, and also we'll go with this infix, prefix as well as postfix notation, and also we'll going to see about the conversion from infix to postfix, that too by making use of this stack concept. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.